troubleshoot every single thing and figure out.
Okay, Kyla, mute yourself. And I think you guys.
All right. Hi, everyone. It looks like we're live on YouTube, so thank you so much for coming out for our career chat today, our scientist chat today. I'm really excited. We have Jennika Greer here, who is a scientific affiliate at the Field Museum. Yeah, research scientist at the Field Museum, right?
Yes, resident graduate student.
Resident graduate student.
There's a bunch of fun titles.
Yeah, there are a ton of fun titles at the Field. So I'm so excited for us to get started. I'm going to kick it over to Jennika to tell us a little bit about herself, and then I can't wait to ask all the questions you all submitted in advance. So I'm excited. And just a little orientation to YouTube. Don't forget that you can still drop in questions in the chat on the right. And if you hear anything that you want to learn more about, definitely type that in too. And with that, I'll turn it over to Jennika to give us a little introduction to yourself.
My name is Jennika Greer, and like I said before, I am a graduate student. So while I'm a graduate student through the University of Chicago, my advisor, the person who's responsible for training me to be a scientist, he's actually the curator of meteorites, gems, rocks, and minerals at the Field Museum. So I spend a lot of my time at the Field Museum, and it has a bunch of instrumentation that I use. And I call myself a cosmo chemist, which means that I study space rocks. And as you go further and further into cosmochemistry, you can break that down into even smaller and smaller projects. So specifically, I look at pre-solar grains, which are grains that are older than the solar system. And I've also been looking at space weathering on the moon.
Those are two really cool things. I'm just kind of mind blown that like you can study that and that it exists, because it's just so awesome. But one of the questions we actually got was from Miss Lohi's class at Parkview Middle School. Their 8th grade class, 8th grade Earth Science class, was wondering, how did you know you wanted to pursue a career path like this, and how did you like narrow down to your focus?
So I remember that thought process because I think it was maybe when I was in high school. Like I had never taken an astronomy class. I hadn't taken a geology specific class. Like I took science classes. But I remember thinking like, okay, the Earth is really small and the universe is everything else. So why aren't there more people studying what everything else is? Because there's just so much out there. Just like to broaden your mind and like study something besides this tiny blue dot.
That's awesome. That's cool. So how did you go from having that idea to kind of where you are now?
So in high school, I was not like, a super sciencey kind of person. I was actually like more like into English. Like I wrote poetry. I was in art classes, and I just decided that I was going to go to college and study astronomy. And because it just had to be done. Like you have to study the universe. It's so big and there's so much we don't know. And when I was in my 2nd year of college, I went into a physics 3 classroom for the first time. And the professor gave a little introduction, which had me leaving that class crying because it's like, I can't do this. I can't do this. But I very quickly was like, okay, what do I really want to study in space? And the answer was rocks. So then I shifted to more of a geology-centric field of study. I briefly worked as an undergraduate in a lab before moving on to work on my master's in astrobiology, which is the search for life on other planets. And that's when I was doing my master's, that's when I heard about pre-solar grains. And I was like, there's stuff that was formed in stars and it's on this planet. Like, I have to study this.
Yeah, can you tell us more about pre-solar grains? I think it's like something I was not familiar with until I met you and started hearing about it a little bit. But can you tell us a little more about that, and like, what does it actually mean to study them? What does that process look like?
So first, actually, can I share my screen? Does that work?
Yeah.
Oh, this is disabled.
We will get that up and running in, I'm sure, a few seconds. Yeah, it should work now.
Okay. So this is just like showing the life cycle of a pre-solar grain. So you start out with a star, and these pre-solar grains either form in a dying star or in like the supernova explosion that is the dead star. And then it floats through space for some amount of time. And then it was incorporated into our solar system when it first formed into these asteroids. And then what we have to do in the lab, so this is a box that's about that big of a bunch of fragments of meteorites. And then what we do is freeze thaw, disaggregate them, which means we dip them in tubes. So all these tubes have these fragments in them. We dip them in liquid nitrogen, so it freezes. And then we put it in a pot. So this is a cook pot on a hot plate with really hot water. And that kind of turns the meteorites into like a sticky paste as opposed to rocks. And then we dissolve a lot of the meteorite in acid, and hopefully what's left over is pre-solar. So
That's
then
so cool.
we actually have to start, deciding what sort of analytical techniques we want to use. What exactly is the information we want to get out of these grains?
Yeah, that's awesome. It's so mind-blowing. So like, is it like stuff around? Like, is there a specific spot you can go to look for things that might be pre-solar grains, or is it like anything on the Earth? Dirt I could pick up could potentially be have solar particles in it.
So the Earth is really, really geologically active. So there's so much going on that is changing the materials on this planet. So when we're like thinking back to some of the work I did previously, I was working on early Earth. Like what were the conditions on Earth when life first arose? And in order to look at that, we have to look at the really ancient rocks, and there are not a lot out there. When we look for these pre-solar grains, we have to go even older. So we're not only looking at material that is in meteorites, we have to look at material in the most primitive and unaltered meteorites. And there are, not as many of those. And also you have to find a meteorite that people are willing to let you dissolve in acid in order to get these grains.
Yeah. Well, we actually had a question from the audience. So Amani is wondering, what are some things you found out about that you didn't know at first?
Like in becoming a scientist or in the science?
Maybe let's do one of both. What's something you didn't know about that maybe surprised you about the career path you chose, and maybe something you didn't know that you found out about in regards to the science?
I feel like I was always really terrible at math, and I thought that I couldn't be a scientist because like I was really bad at math. But it's so much easier to learn that stuff when you find something that's like actually really interesting. Like, I mean, I probably couldn't like open up a math textbook and do all of the problems in it, but if it was something that I really needed to understand in order to understand my samples, like I can figure it out. And I don't think I necessarily felt that way when I was in middle school, but like I'm surprised that they let somebody who was as terrible at math as me become a scientist.
And what about something scientifically that you found out about that you didn't know at first?
Well, pre-solar grains blew my mind. Like I had been in college for 4 years, and then I was working on my master's degree, and then it was just mentioned like in one class, and it's like, how is everybody not talking about this? Like why don't more people know? Like this is stars. We're holding pieces of stars in our hands, and it's older than the solar system. Like, how is this not something that everybody wants to study? And I'm actually kind of surprised at how small the community is, because, you know, when we're looking at these grains, not only are we looking at something that is extrasolar, so something from outside our solar system physically, like astronomers look at outside our solar system all the time, but they only have light. We actually have something physical. We have something we can hold in our hand. And we can actually figure out what happened before our solar system formed, before our sun formed. So
one of the reasons I love talking to you is like your passion comes through so much, and that's just it rubs off on me, and like I'm excited and inspired by it. So just one of the questions is that segues really well is from Mr. Hall's 8th grade physics class at Finley Junior High. And they were asking, what is the most interesting rock you have touched or researched?
That one's of course difficult. It's like, you know, asking what your favorite candy is. Because also, like, I have held a piece this large of the moon in my hand, but I had gloves on. So does that count? Like, I haven't like touched the moon with my bare finger, because we would never want to touch a meteorite with our bare fingers. But like, I've held pieces of Mars, I've held pieces of Vesta. You know, I've held these pre-solar grains.
Yeah.
I guess the coolest thing that I've probably touched with like my fingers is the layer that has an increased amount of iridium that that shows where the dinosaurs went extinct because of an asteroid impact.
Wow. Okay. Just no big deal throwing out those really cool things you get to do. I'm kind of mind blown. So another question coming in is like, why do you like being a scientist? What are some of your favorite parts of it now?
Well, I like being a scientist because I like knowing things. Like, it's not just that I'm learning stuff, like, you know, reading out of books, because that's a big part of it, is like understanding what people have done before you. But like, as I'm studying this stuff, like, I become the world's expert in it because I'm the only one who knows about this specific thing. And by doing that, I am like actually creating knowledge. Like, I am learning about this stuff, and I am creating the stuff that will be put into textbooks, put into books. But also, I get to be really creative. So it's fun to go into work and maybe something goes wrong, maybe the instrument doesn't work, and just having to think of a way to work around that. It's really fun, I think.
That's interesting, because my next question was is asked from Giselle, which is, what inspired you to become a scientist? And I'm really interested also in, like, you were talking about how earlier you were really interested in like English and arts and kind of like, and it's interesting you used the word creative to being a scientist. So I don't know, can you talk about how you decided to really make that jump into being a scientist instead of using your arts to be involved in science?
That, I think it's just like the subject itself inspired me. Like, you know, you can go on like the NASA astronomy picture of the day and you see all this really cool stuff. And, you know, at first I wanted to be able to create that. Like, I wanted to be able to make art like that. But now, like, it's so hard to go there and stop, to just look into it a little bit and then decide, no, I'm done learning, I'm going to go somewhere else. It kind of, the field pulled me in. So, I mean, it's not that there's like a specific person or a specific event. It's just, you know, as you learn one thing and then you search a little more and then you search a little more. And then before you know it, you're a scientist when, yeah, you didn't mean to be.
I love that. Diana actually asked in the chat, if you weren't a scientist, what would your job be?
So I guess the 2 jobs. Like there's one job that like I would really want, but I don't think I could get, and that would be like a video games journalist, like reporting on like new releases and like doing the like early access stuff and playing games for fun. But you know, that's like really hard to get into. So I think like maybe I would be a writer, not like science papers, but like fantasy novels.
Nice. I feel like out of this, hopefully someone who makes video games is watching, and you can make a video game about pre-solar grains and the journey. I don't know, come up with something there. So another question coming in is from Emilio, and also relates to a question that Mr. Hall's 8th grade physics class asked, which was kind of about what are some of the obstacles and most challenging parts to being a scientist?
Yeah, I've been thinking about this a lot. And one of the things about being a scientist is that when you're at your job, when you're working on your science, the job of other scientists is to make sure that what you found and what you think you found is correct. So scientists are always questioning each other. They're always probing, seeing if you did something wrong, you know, trying to figure out what you did and constantly questioning you. It's constant questions, and that's good. That's how science becomes, you know, even better, like when we try to figure out more and more about a subject. But what's been really hard recently is the questions that come in from outside the scientific community that are less that don't come from a place of wanting to understand better, but wanting to restrict knowledge. Like in this current climate, you know, you see so many people who don't listen to doctors. And the same is true for pretty much any field of science. There are people who will not believe you no matter how much evidence you give, and it can be very disheartening.
Yeah, wow. That's interesting. And yeah, I guess I wouldn't have expected that in such a small community. I mean, I guess the natural follow-up is like, what are some of those dissents, or like, what are some of the common myths or like things that we can kind of debunk a little bit?
Well, I guess one of the things is like, scientists are being paid to do this, like to say something. It's like, I am not getting paid. Like, I wish I was getting paid because, you know, I could use the money. Like, there is no scientist, I don't think, who is in it for the money, because you don't make crazy amounts of money by being a scientist. You do it because you can't think of anything else you can do. You just have to be learning and learning and learning. So there are people out there with agendas. There are people out there who want to tell only one side of the story. But for the most part, people are trying to understand the world better. Like, yeah.
I love it so much. Well, Hugo actually was wondering from the chat, like your research, and why would you say that matters?
So sometimes I compare it to, okay, you wake up and you're in a completely dark room and there's no light, you can't hear anything, there's just nothing. Like, what are you going to do? Are you just going to sit there waiting, or are you going to try to find out more about the world you live in? Where are you? Like, are there walls to this room? Like, is there a light switch? Is there somebody else in the room? Like, you're going to call out, try to, you know, find out what's going on. And that's a lot of what we do, is we're trying to figure out where we are in a broader context, and how that happened. So why do a bunch of elements like nitrogen and carbon and oxygen come together to form a planet that can support life? So, and by understanding this stuff, like if you want to put a commercial value on it, like meteorites, they are they're very mixed bags. They contain a lot of rare elements that are rare on Earth's crust. So if we combine a meteorite, we would get a lot of these rare metals. But really, like, how do you not want to understand the world you live in?
Yeah. Actually, someone had a follow-up about the science and art connection we were making earlier. Nathan was wondering, does being a scientist have any art in it?
Yes, for my part, it does. I frequently will draw my own figures to better explain the science. So like that's something I like to do. So I had a friend who wanted to show the life cycle of dust in the galaxy. So I drew her a figure that basically showed that. Or like my advisor, he's hosting a conference next year, and I drew the logo for that. So wherever I've been able to, I've been trying to figure out a way that I can do some art for it.
That's awesome. That's really cool. And wow. Kaden was wondering, what are some things you've discovered lately, or what are some of your, I know you've been working on pre-solar grains, would you talk a little bit more maybe also about your Apollo 17 project?
Yeah, so so the spinning cone over here, I don't know if it's spinning. This is some of the work that I've been doing. And what it shows is every single little dot in that is a single atom. And they're all color coded to a specific element. So like you can see there's like a bunch of orange up here. That's iron. And yeah, there's like, it looks yellower up here. That's silicon, but it's the individual atoms. We're looking at single atoms. And what I've found is that just by looking at the very outermost surface of this grain that was picked up by an astronaut from the Apollo 17 mission, is that in the outermost 100 nanometers, so we're talking really, really small, something as barren as the moon actually has water. So because of the interaction between the moon's surface and the sun, water actually forms in this layer. So that could be a really important resource if we were to have a moon base.
Wow, that is unreal. Kind of mind blown that you can do that. And I was looking at all those colors, like, do they mean something? And they do. So that's pretty crazy. Thinking about, we only have time for a few more questions. So two people have kind of, Dainara and, oh, sorry, I'm scrolling, but I want to get everyone's names. Dainara and, let me find her name, Darnella, we're wondering, what is some advice you have for future scientists?
It's going to be hard. Like there's a lot of things that make it hard. Like sometimes it's other people, sometimes it's the work you're doing. If like, don't give up. There's going to be a time where like nothing makes sense anymore. And that's usually right before you finally start understanding it. There's not a single scientist who has been in a place where they're like somebody has struggled at some point somewhere, and you just kind of got to keep at it. You got to keep thinking. And if there are people in your life who support you in that, those are the people you want to stick by you.
Yeah, I love that. Well, this last question is a fun question. We shared with everyone earlier that in our pre-slides about your puppy Sputnik. And so, is he here?
Yes, come on, Sputnik. Oh, he's not going to be happy. I woke him up from a nap.
Oh, well, Kathleen was wondering, does Sputnik live up to his name? Does he instill fear like the original Sputnik did?
Well, he doesn't instill fear.
Yeah, I was gonna say, I'm like, oh, good, he's so cute.
But Sputnik means fellow traveler. And like he is kind of my fellow traveler. He's, so right now we're in Colorado, but he's been with me in Chicago. He's just, my little traveling buddy.
Oh, I love that. Oh my God, we need to like screenshot that frame. It's really fun.
Like,
Well, thank you
let me
so
go back
much,
to my map.
Jennika. This has been fantastic. I've like genuinely, you just have so much joy for what you do, and it's so nice to get to experience that on the other side. And to all you viewers, thank you so much for all your questions. And I hope like out of this, you're inspired to continue pursuing your passions. And if it's science, then do it. It's going to be a hard journey, but worth it is what I'm taking away from this. I don't know if you have any last thoughts, Jennika, you want to share?
Yeah, don't give up, and don't think you can't do it because you're not good at something. There is some aspect that you're good at that will make you a great scientist. Maybe it's art.
Yeah. All right. Well, thank you everyone, and have a great rest of your day. Bye.